Greetings! We are the Maxwell Group 5, and today we will be discussing about the Fleming's Rule.
Meet the group starting with Jello Joy Balsicas, Jelender Grant Estoya, Audrey Daniel Evidente, Shem Serge Francia, Lee Brian Pescuela, Kiana Angela Provido, and last but not the least, Julian May Tubid. Contents: 1. Who is Mr. Fleming? Background. 2. What is the right hand rule? Concept and examples. 3. What is the left hand rule? Concepts and examples. 4. Importance of Fleming's rule, practical use, and last but not the least, 5. References.
Who is Mr. Fleming? John Ambrose Fleming was an English engineer who made numerous contributions to electronics, photometry, electric measurements, and wireless telegraphy. He studied at University College, London, and at Cambridge University under James Clerk Maxwell. Fleming became a consultant to the Edison Electric Light Company in London, an advisor to the Marconi Wireless Telegraph Company, and a popular teacher at University College in 1885 to 1926, where he was the first to hold the title of Professor of Electrical Engineering.
The hand rule. The hand rule demonstrates the direction of the three parameters, including magnetic field, current, and force, when the other two parameters' directions are known. Representation of the fingers. Thumb. The thumb is a representation of the direction of thrust on the conductor. Index, also known as the forefinger. This represents the direction of the magnetic field. Middle, also known as the center finger, is representative of the direction of the current.
The right hand rule. According to Fleming's right hand rule, if we arrange our right hand thumb, forefinger, and middle finger perpendicular to each other, the thumb points in the direction of the conductor's motion relative to the magnetic field, and the forefinger points in the direction of the magnetic field, and the middle finger points in the direction of the induced current. On the next slide, you will find an example of Fleming's right-hand rule.
The left-hand rule. According to Fleming's left-hand rule, if we arrange our left-hand thumb, forefinger, and middle finger perpendicular to each other, the thumb points to the direction of the force experienced by the conductor, the forefinger to the direction of the magnetic field, and the middle finger to the direction of the electric current. This slide shows how Fleming's left-hand rule is properly performed.
The right-hand rule and the left-hand rule are two useful guidelines that help us comprehend the relationship between electricity and magnetism. When the magnetic field direction and current direction are known, Fleming's left-hand rule is a simple and accurate approach to find the direction of force or motion of the conductor in an electric motor. When a conductor connected to a circuit travels in a magnetic field, Fleming's right-hand rule for generators shows the direction of the induced current. Hence, it can be used to determine the current direction in the windings of a generator. Lastly, here are the differences between Fleming's left-hand and right-hand rule. Fleming's left-hand rule is used for electric motors. Its purpose is to find the direction of the magnetic force acting in an electric motor, and the middle finger represents the direction of the current, while on the right-hand rule, it is used for electric generators. Its purpose is to find the direction of the induced current in an electric generator, and the middle finger represents the direction of the induced current.
Sometimes physics and nature go hand in hand. In this video, we're going to look at using Fleming's left-hand rule to help us remember how current, magnetic fields, and direction all go together. First, let's talk about the motor effect. A wire carrying a current creates a magnetic field. This can interact with other magnetic fields causing a force that pushes the wire at right angles. This is called the motor effect. So magnetic field from north to south, the current going this way, and the force at right angles. We can use our left hand to help us remember what direction the wire is going to be pushed in. It's called Fleming's left hand rule. With your left hand, spread out your thumb, first finger and second finger, so they are all at 90 degrees to one another. Your first finger represents the direction of the magnetic field, from north to south, so your finger is pointing to the south pole. Your second finger represents the direction of the electric current, flowing from positive to negative, so your finger is pointing to the negative. Your thumb represents the direction of movement. Try to remember it this way: thumb, movement. First finger, magnetic field. Second finger, current. Let's try using Fleming's left-hand rule to answer a question. Pause the video and see if you can answer them. For A, hold up your left hand in the current position. Magnetic field is going from north to south. The current is going in this direction, so the force is going up. For B, the current has changed direction, so you need to rotate your hand around. So that's how physics and nature go hand in hand. We literally use our left hand.
Thank you.